Hi folks, so in this video I just want to do a quick explanation as to what the graph of an exponential function looks like. So remember that our exponential function has the equation y equals a times b to the x. And remember that a is our y-intercept and b here is our multiplier. Again, that's, if we're comparing it to a linear function, that's synonymous with or analogous to the slope of a linear function. And so I'm not going to go through and creating a table for every single scenario, but because I think, well, one, you could do that. But I think we can see here what's going to happen. So if our a is positive, our y-intercept is positive, well, that's marked off right there by those 2 points. Then what could happen? Well, if that's the case, if our b is greater than 1, so for example, our b value is 2, 3, 4, 5, and so on, heck, even 1.1, what's going to happen? Well, if you take a number, whatever your starting value is, your y-intercept, and you keep multiplying it, so going from left to right, you're multiplying by whatever your multiplier is, left to right in the x direction, I mean. If you're going to say times 2 times 2 times 2, your function is going to get bigger and bigger. And so that's what I mean here. Your y value is going to get larger in size, or at least larger in absolute value. And the reason I'm emphasizing absolute value here is because the same thing can be said when a starts off negative here. So if, for example, your a value is maybe -1 right here, and you just go times 2 times 2 times 2, well, yeah, it's getting more and more negative, -2, -4, -8, and so on, but its magnitude or its size is getting larger. And so larger meaning farther away from 0. And so that's why in these two scenarios where if b is greater than 1, your y values get farther and farther away from the x-axis. And by the way, at the end of the video here, we'll play around with Desmos and just see this in actual action, just so you actually believe me. So when our multiplier is greater than 1, our function gets bigger. And that makes sense because, well, if I multiply by 1, you stay the same. So if you multiply by something larger than 1, you get bigger. If you multiply by something smaller than 1, well, it makes sense that your function gets smaller, closer to 0. And so that's why we see this happening in this scenario when b is less than 1. Notice that I did say over here, though, b does need to be positive. And the reason being, the reason being is because if b is negative, you get some weird results, and which we will actually talk about later. Okay? So let's actually hop over to Desmos and just see this in action. Alrighty, so here we are in Desmos, and you can see here I set my a value, my y-intercept, to 1.5, and my b value, oops, sorry, z is not there, is 1. So it's a flat line, which is actually not surprising because a multiplier of 1 is just times 1 times 1 times 1. Nothing should happen. Okay, sorry, let me readjust my window here. Okay, so there's my graph. And so if I increase my b value, we can see that the graph gets curved upward. Again, going upward from left to right. If I increase b, what happens? Well, similar to think about a linear function, if the slope or the growth rate gets bigger, then your slope gets steeper. And so a similar thing is happening here where our function is actually growing faster and faster and faster and faster. And as it goes back down, well, it gets flatter and flatter, like so. And we can see here, again, if my a value increases, then that also has some effect on the curvature of the graph. It's a little hard to see. It is not just shifting up, it is actually kind of curling up and to the left. You can kind of see as as a increases. But the important thing here is that our y-intercept is actually changing. And of course, if a is negative, then our graph goes negative. Notice that also, we can talk about the domain and range of this briefly, but in the next video we'll go into more depth with that. Is that whatever a is seems to affect the range, right? If a is positive, then it looks like our y values, even if I scooch over here, all our y values are still positive. They don't go negative, it seems, as we keep going. And if a is negative, it seems that all the y values will stay negative. And again, we'll talk about why that is the case in a future video. Okay? So again, to get the shape of an exponential function, if you just know the equation, you know already what the shape looks like. If the y-intercept is positive, the graph is going to exist above the x-axis. If it's negative, it'll be below. And if b is positive, then it's going to get farther away from the x-axis, again going left to right. And if b is positive but less than 1, it will get closer to the x-axis, again going left to right. And again, remember that this is important. B has to be positive, non-negative rather. If b is negative, then weird stuff happens, or even 0, weird stuff happens. And I'm going to leave you to that. Okay, so thanks for watching, and I'll see you in the next one.